Hi, my name is Stephan Wolf. I'm systems engineer at VMware, and today I want to show you how to use very common features in the vSphere distributed switch that eventually you not know. So the vSphere distributed switch is there for years in our hypervisor, but the most people don't know what they can do exactly in depth. And this is what we want to discover in this session. So let's go in the slides. This is the disclaimer. And we want to do the following things in this session. We will have a look on all the features that the virtual distributed switch is able to provide. What power are in these features? We want to see the VDS Health Checks and how they can help us to find problems in the infrastructure. We want to see switch discovery protocols that help us to troubleshoot connection problems. And we want to see Netflow that helps us to see the communication relationships between VMs. Okay, let's go in. So first of all, what's the difference between the standard switch and the distributed switch? The standard switch is the standard switch that comes if you install ESXi on the host. And if you have 100 hosts, you have 100 single switches, and every switch have to be managed separately. To solve this problem, especially if you have to modify something and you don't want to do it 100 times with 100 hosts, you can just use the virtual distributed switch. And the virtual distributed switch, just say, okay, you span one single switch over all these 100 hosts. And then if you configure something like a VLAN or other modifications, all the hosts will have this modification at one time. So what we can do, except the health check we will discuss later on, we can also do things like LLDP, we can load-based teaming, we can do quality of service, and we can do pod mirroring. So a lot of features are embedded in the virtual distributed switch, but often not used by the customers because they don't know what the virtual distributed switch can deliver. Okay, let's go in the VDS Health Check. VDS Health Check is also there for years and can help a lot if you are a system administrator, because it helps you to see, is there a missing VLAN on my physical switches? So the health check really checks the physical switch. Is the physical switch able to have all the VLANs that I need on the ports of the host? Is it really the right MTU in place? So especially if you're using storage networks with iSCSI or other storage protocols and overlay networks, for example, for NSX, then you need a bigger MTU, 1,600, 1,700, or even more for storage networks, sometimes 9,000. And for sure, if you're using LLDP or other port channel mechanisms, you can check whether the switch are also right configured and check whether this connectivity really works. So how this works? Let us imagine we have here now two hosts. This is the ESXi host 1, and we have the ESXi host 2. And we have a port channel group, we have a port group on it with VLAN 5. And we have here below a physical switch, and the both hosts are connected with 2 times 10 gigabit VMNIC 1 and VMNIC 0. So how we do these health checks? So how we can check whether the VLAN 5 here is really configured and right configured on the physical switch. How are we doing this? So we do it very easily. We just create a virtual MAC address for every physical NIC. So for example, for the physical NIC 0 and for the physical NIC 1. Same on the second host. We do it in the VLAN and we create the MAC address for VMNIC 0 and VMNIC 1. And then we're sending a probing packet from the first host or the first NIC over to the second host in the first NIC. And then we do the same with the second, probe packet. So we send over the probing packet to the other NIC, to the second NIC on the second host. Then we send from the second NIC, first host, to the first NIC on the second host. And after it, we send over from the second NIC, first host, to the second NIC second host. And we do this vice versa. When it happens, then we can probe vice versa back these packets from every host over every NIC over every VLAN. And so we can find out on which port of the switch eventually is a VLAN missing. So let's imagine we have an error in our health check. And for example, we see here a warning. We click on the warning, we click on the host. It's on the first host here. And we see in the details below, and then we see, oh, VLAN 5 is missing on the VMNIC 1 on the first host. Okay, we want to investigate it. And we want to see, okay, which is the opposite port on the physical switch, on the Cisco switch, for example, that we have. We can do this with switch discovery protocol. So we want to know which is the, on which cable, on which port is on the physical switch is the physical NIC of the server connected. And we do this with switch discovery protocols. We have two protocols in place. One is LLDP, Link Layer Discovery Protocol, which is the open standard, and Cisco Discovery Protocol, which is the Cisco proprietary one. And these both protocols are working very similar, and they just do a connection mapping. They just say, okay, we have two ports, they are connected to from one switch to another switch. And if you have a network with several switches, we see all these connections and we see from which port, which device, port number, and device number, we see all these connections in. And for sure, because the virtual distributed switch is a switch, he's also able to speak these protocols. And how this works. We go in the virtual distributed switch, we enable link layer discovery protocol, and we enable both. So both means we just send these informations and receive it. So as the hypervisor, we say, hello, this is my port 1, this is my port 2, I'm the hypervisor number 1, E6I host 1 or E6I host 2, and these are all the informations that I can give you. And same is vice versa. The Cisco switch will be also configured with CDP or LLDP, and then they give us their information. So, and when we have configured this, then we can go, for example, to a VMNIC 2 and say, okay, I want to see who is the opposite port. So on in my server, I have the VMNIC 2, and this VMNIC 2 is cabled to a top of rack switch. And the top of rack switch is here the Cisco switch, and the Cisco switch has the host name W3, and it's connected to the port 33 at the end. So, and now I can go to the network administrator and say, hey, Mr. Network Administrator, I'm missing the VLAN 5 on exactly this port. Same, the opposite. If we now go via SSH with the network administrator on the Cisco switch, we can see these ports here and say, okay, on the local port 17 and 18, for example, on the Cisco switch, we see, for example, the VMNIC 6 and VMNIC 7 port. So with these, for sure, these screenshots are not matching directly with the numbers, but you know what I mean? We can exactly see from both sides the mapping of the ports. So which local port of a device is connected to a remote port. In this case, the remote port is the server because we are on the switch are connected. So, and what we have in the IPFix and Netflow space. So in traditional networks, we want to analyze eventually also the communication between the VMs. So we want to know which IP address speaks with which IP address. And we can do this with Netflow and IPFix. These are standard protocols and gives us the metadata of the communication. So for example, we have here the virtual distributed switch. We have the E6I host. And we want to see the communication of the VMNIC 1 and the VMNIC 2. And we see the communication between them and also when they are in the same hypervisor. This is important because if you just collect the net flows from a physical switch, they will not see what's happened inside the hypervisor. But if we enable Netflow on the virtual distributed switch, then we can export these Netflow data and see, okay, which is the source the IP, which is the destination IP, which is the source port number, which is the destination port number, and bandwidth and volume data. And here's a screenshot from Network Insight, from vRealize Network Insight, and it shows, for example, that the IP address 11 speaks with the IP address 12 on port 8080. So this is a web server that speaks with an application server, and you see the communication. You see how which traffic volume is used in the specific time frame, so how much data are transferred, and you see also the traffic rate, which means the average bandwidth that is consumed by these applications. And with this data, you can do a very good and easy troubleshoot. So you see, these are just 3 examples of how the virtual distributed switch can help in the daily operations of a system administrator. You can test these operations also in the hands-on labs. We can just go on the VMware hands-on labs. You can create an account for you. With every administrator of your team can just create an account for himself and use that for free 24 hours a day, and can use live exercises. So these labs will be rolled out automatically. And I recommend here a lab. I wrote it on the slide that you can just search for it, the 221091. And there you have a really good example of the vSphere distributed switch. And on the doc side, which I mentioned here, you can find the appropriate documentation to this lab with exercises, with screenshots also in the exercises. So with this, I want to close my session. This was a session from me, Stephan Wolf, for you. And if you have any questions, you can just send me an email if you want. And thank you for your attention, and bye-bye.